Alex, great to be speaking to you again. So obviously today we're going to drill into a little bit more of what Intel are doing in the AI world. I think for me, the easiest place to start is a very simple and fundamental question. Why Intel, and what's Intel been working on sort of around AI sort of over the last 12 to 24 months?
Yeah, absolutely great question. I think actually looking at the last 24 months, especially the last 12 months, right, there's been so much change naturally anyway. And a lot of things have, from a business perspective, have just naturally changed and just gone more digital very quickly. And I think for a lot of people as well, using this time to actually invest into either learning something new or to change kind of business practices has been really, really valuable, where it's been where customers have been able to do that. So, really from our space, a lot of the work we've been doing over the last sort of 12 months, and we've been many years throughout this journey making sure we're enabling the software side, but we're really doubling down on what we can do to kind of enable the industry-wide software ecosystem and make sure that we're aligning our sort of hardware products to make sure that we're really making it as easy as possible for developers to go and start deploying those workloads, and especially making sure they can accelerate AI really easily without having to spend an enormous amount of time trying to understand every single nut and bolt of how they can go and get a bit more performance from their hardware in their data center.
Yeah. I mean, it's interesting that you focus very much on the software side there. I mean, AI itself is very software centric. Intel is traditionally this, massive hardware platform. You've got the CPUs, the drives, the chassis, persistent memory, networking. That's everything that Intel have been known for doing for such a long time. I think it was the last generation of scalable CPUs, Deep Learning Boost, that was launched.
Absolutely.
Can you just sort of give us a bit of an insight into what is Deep Learning Boost, any other sort of optimizations, or what do those software stacks look like?
Yeah, absolutely. So with Deep Learning Boost, it's something we introduced into our second generation scalable family, which was introduced a couple of years back now. And we made some optimizations to it once again when we released just a couple of weeks back our third generation scalable platform as well. And really with the Deep Learning Boost, it's a way to make sure that we're able to go and accelerate AI deployments really, really effectively onto a CPU-based deployment or into a CPU-based workload, especially when they're going and deploying that maybe into existing infrastructure or even deploying a completely new cluster for this workload, for example. So really with Deep Learning Boost, it's a way to take a workload and part of the process is taking what you used to take actually 3 separate instruction sets to be able to process this and combine that into one instruction and then heavily optimize the software stack around that. And really with that, you're able to get a huge improvement in throughput when you're doing inferencing on the CPU as well. So, we've got really great case studies and, lots of deployed examples of this. And a lot of open source information as well around it to make sure that if you've taken a third generation platform or a second generation platform for that matter as well, you're really able to take your deployment and push to that next level of performance as well. And that that's really taken advantage of kind of the VNNI instruction sets which are baked into the CPU, as well as utilizing some of AVX 512 as well in the platform.
Okay, I mean that explains it all really well. I think it's interesting that obviously more recently, you said the last couple of weeks, that the third gen scalables have sort of been launched. A phenomenal sort of leap in performance. Have you got anything that you can sort of benchmark for comparison of where that's sort of taken Intel from second gen to third gen, what that looks like from an AI perspective?
Yeah, absolutely. So, there's a couple of parts to it, really. I think, just looking at the third generation platform as a whole, we've got some really big in performance improvements across the board, across every workload on this new platform. So we've got much bigger capacity for larger memory pools. We've got more memory channels. We've got some really great instruction per clock improvements as well on this platform. And as we mentioned in that last question, we're accelerating, we're driving more into that deep learning boost and doing some of the optimizations around there. But as well, we're making sure we're aligning this a lot more closely to a lot of the open source and the ISV partners we've got from a software perspective as well, who are, developing and making these AI deployments accessible and scalable, for customers, which, us and Scan, we work very closely with as well.
Yeah. One of the interesting things that I saw, looking at the actual the specs of the third gen, was the interesting inclusion of obviously up to 4 sockets of and using persistent memory to get 6 terabytes of memory per socket. That is a phenomenal amount of system memory. Could you run us through some of the basic calculations, some of the maths of how that stacks up, in terms of basic RAM to persistent memory, what the recommendations are, and then the types of people that would benefit from having such a large amount of system memory?
Yeah, absolutely. So we introduced persistent memory onto the second generation platform when we launched it, and that was with our 100 series. And we've brought out a new version to align with some of those extra performance bumps on the memory side with our third generation platform. So that's the Optane persistent memory 200 series we've released for the third generation platform. And really with this, and we've got some really easy to understand guides about how you can go and integrate this into your system. What the recommended configurations are. But when we look at it in terms of going to deploy it, there's kind of 2 different operating modes you're able to use with it. There's what we call app direct mode, which makes it effectively a usable memory or storage volume, which you can go use, and it's completely byte addressable. Or on the other side, you can use it to expand your current memory pool as well. And I think specifically when we look at AI deployments, and not just it being deployed in the data center and having that consolidation of infrastructure, but actually for the actual data preparation journey, the data scientists going all the way from that initial concept all the way through until you get to that production level. There's a lot of value, and you see this a lot of the workstations which those data scientists are using these days. They're already using multiple terabytes of memory in these workstations. So being able to expand that and just unlock even greater resolution for data sets, or maybe even go to the ability in some deployments where the workstation users, they're not actually having to tile their data set or do any downsampling anymore. They can just run the data set natively in memory and still get those ultra fast performant memory access to their data set as well. And that, in many sectors, you can't actually go and sort of very easily downsample your data because you're going to be losing accuracy at that point. So that's a really important step. And it also brings the developers who are working on the model very much into a league where they're so much more close to what the actual server infrastructure then looks like, right? Because they're not having to do something different on the workstation, and then they see something unexpected when they go deploy it. They're kind of almost working on a one-to-one configuration going forward, and that just streamlines it for everyone involved in that overall journey. And I think when we look at AI, and Daniel, we've had conversations about this. It's very much a journey, right? Going from start to finish. It's a long journey. It's a complex journey.
Yeah.
But anything you can do to simplify any of those very nuanced steps all the way through massively improves the experience for any business or any developer looking to just extract more insight.
Yeah, I wholeheartedly agree. I mean, that's we sort of engage very much at that consultative level where we're taking people from that development, training, and then inference stage. I think that's one of the beauties that Intel have. As I mentioned at the very start, or as I mentioned earlier, Intel have this wide range of hardware there. You've got the CPUs, ranging from the desktop grade CPUs, the workstation CPUs, then the Xeons. Persistent memory, you've got the SSDs, the networking technologies, and the actual building of the chassis. That gives you that full-on one-stop solution. Do you see benefits from having that all in one particular chassis from a data center perspective? What kind of person is it? An IT manager that would benefit more from that? Is it the entire business? What do you think that the sort of advantages are of having Intel deliver that one platform?
Yeah, absolutely. Great question. And we really lean into that complete platform solution because we're in a really unique spot where we're able to offer that complete platform as you mentioned, right? And it also is very important for looking ahead when you want to go and scale your workload or your model, for example, because it means that you're not kind of just locked into what you've got currently available. For example, if you've got something which is currently running on the CPU and you want to go maybe and do more real-time insights, you've then got an Intel FPGA, which then can use and inherit some of the same code base, and you can go and scale that way. Or if you need to start, populating more memory, we've got that persistent memory to go deploy with as well. And then it also becomes that greater story around, AI models are very rarely deployed in isolation. There's kind of a complete solution around them.
Yeah.
And we saw this quite a lot when kind of the 4G expansion came out, and it had those knock-on effects across the whole industry. And we're definitely seeing that with 5G as well. And it kind of comes back to that point in the previous question where, as these data sets are getting bigger, and they're going to be able to get bigger now because there's more bandwidth in the networks to support that, there's absolutely going to be that overall growth. So, you can really use this to kind of start on a CPU-based deployment, use our optimized software, use the optimized frameworks, and then kind of go and, choose your direction depending on how the workload takes you or how kind of the business imperative take you as well. But, it really does make that journey simpler when you've got just one partner to go and, look after the entire code base. And especially when and with us, we're so deeply involved with the open source ecosystem that it means that you've got that flexibility to experiment and to make sure that you're staying really on that cutting edge of where the developer ecosystem is moving.
Yeah, that I completely agree. I think that having that simplicity of being able to move everything across one platform, as you say, AI as a journey. A lot of people consider that very much as, people liken AI to the data scientists because they're the ones that are creating the models, but it is very much a bigger beast. It is more than just the data scientists. You've got a good chunk of a typical AI workload is taken up with the data pre-preparation, data pre-processing, shaping that data, getting it in its right format for the data scientist to go and create that model before you then go and take that on and sort of implement it at the other end.
Absolutely.
Yeah. Have we got any sort of software tools that sort of simplify that process that works across? Obviously, we're talking about that single code base, but is there anything in that open source world that Intel have or that have worked with that allows all of that to seamlessly work and then work with the network managers as well?
Yeah, absolutely. And I think this actually lines up really nicely with one of the tools we've been working on a lot, and we've kind of inherited a lot of this from the open source community as well with OpenVINO. I'm not sure if you've come across OpenVINO as well, and it's a really interesting tool. We've got it's effectively, we call it the Intel OpenVINO toolkit, and it shares a lot of the similarities with the open source OpenVINO toolkit itself. But really, what we've done there is we've kind of taken that first step in terms of what we can do to build out more of a heterogeneous architecture across all our silicon. And what we mean by that is it means that you can have kind of one code base. You can have one developer who's has a good understanding of your model, and then they can go and deploy that onto the CPU with all of those optimizations. They can go deploy it onto the FPGA, onto perhaps an integrated GPU on one of our client CPUs, or onto one of our VPUs for very efficient training at the edge or inferencing at the edge. And really with that, when I say they can go and choose what it goes run on, it can be as simple as adding a single flag to the end of their model deployment in their code base. So that really unlocks a new way to go and easily deploy these models, where you're not just locked down to one particular architecture from the get-go. You no longer have to think, this is going to be my architecture throughout the lifetime of the model. It's going to be giving you that flexibility to shift and shape throughout as the actual deployment changes. And it's very common for those deployments to change when they're in production as well. So for example, when you look at training, right, you're not training all the time. You might be training once a week, once a month, for example. And that you can see the case where you might train for your initial deployment and then leave that inferencing going for years and years. But more and more commonly, you're seeing that training regularity become more and more important because the actual data which is being ingested changes so rapidly. So having just that simple code base to go and work off means you can kind of focus on those parts which really increase the accuracy or increase the value coming out of your model, instead of worrying about having to look at this new architecture and having to, really understand the design behind it at every single layer. Just simplifies that. And it's a really powerful tool. And because it's got those optimizations baked in, you're effectively getting potentially free performance when you go and shift from just running it in a TensorFlow or a PyTorch model. When you go and use that optimization engine within OpenVINO, then you're just taking advantage of it for free. So a lot of the time it's kind of, let's try these optimizations. You might not see much depending on the model, or you might see a lot. But when they're available and when it means you can just streamline and potentially take more performance off the table, that's absolutely the way to go.
Yeah, I think you sort of loosely touched on FPGAs there, and I think the flexibility of the Intel ecosystem, of the Intel hardware, and then the flexibility of being able to reprogram, reconfigure the FPGAs almost on the fly. I think that speaks, that is a fundamental part of AI stacks, or it should be at least. Having the ability to, as you say, if in the at least in the beginning bit, the beginning phases of the AI journeys, we do see that a lot. Where people are not training consistently for hours on end, using spare, clock cycles, spare CPU cycles, or then adding in FPGAs, ASICs, VPUs to that hardware stack. Reprogramming those FPGAs when you've got a lighter workload, for example, say of an evening, and it's not required to do specific tasks, you can reconfigure that for AI workloads. How simple is that to reconfigure, redeploy that FPGA? And as I mentioned, you can almost do it on the fly. Is that a complex task? Is this something that is supported? Is there any Intel software to simplify that process? Is it something that a network engineer or a network manager can do with ease?
Yeah, it's a really interesting point. I think when we look at the FPGA space, it's for a very long time been kind of relegated into a space where if you don't have the expertise in house, it becomes kind of a no-go, because it's very much a very specialized way to go and deploy. And really, when you're looking at models which are very time sensitive, you want to get that latency as down as possible, or you actually want to be doing a little bit of especially when you're inferencing, doing some data manipulation before it gets processed, doing some of that workload, that's been fairly accessible with lots of the toolkits from an FPGA standpoint for a little while now. But really with OpenVINO and with some of the Intel FPGAs which align to that, it very much becomes more of a focus on, let's focus on the model and let's focus on the output of the model, and then we can use some of these toolkits to kind of abstract away from the very low level programming of the FPGA. I don't want to take away with it. It's just as simple as on an FPGA compared with a CPU. You can just go and deploy it, with a click of your fingers. There is an extra layer of, tuning, and there's an extra layer of making sure you've configured your FPGA right. But there's a lot of value if you want to, go down that route. And, I think over the next, looking forward, that's going to become a more streamlined journey more and more for developers as well.
So OpenVINO, is that a collection of Intel hardware? Is it the umbrella term that you're giving to the entire AI stack that includes the optimized frameworks? Could you just drill a little bit deeper into what makes up OpenVINO?
Yeah, absolutely. So OpenVINO in itself, I kind of see it as kind of three separate parts within the toolkit. So, really when you look at the journey with OpenVINO, you kind of go from, you've already got a model which might be in Caffe, TensorFlow, maybe you've got something running ONNX, for example. You can take those existing models which may be already in production, and then you can run it through what we call the optimization engine. And really what this does is it kind of takes your model and it converts it from kind of that TensorFlow code or that PyTorch code into kind of an OpenVINO format. And then with that OpenVINO format, you can then have that flexibility to go and deploy onto those different hardware platforms as well. So really, when we look at that toolkit, it's a it's the optimization part of it, and it's also the inference engine as well. So it kind of gives you that whole toolkit to encompass going from a ready to go model to an optimized deployed model.
And sort of trying to again treat this all holistically. How important do you think micro data servers or the edge compute, edge technology, how important is that going to be to Intel's journey, as we move forward over the next potentially 12 months?
Yeah, absolutely. Really for the network side, we're starting to see 5G be more of we've got it ready, we've got industry level 5G deployment, and we want to go and take advantage of it. We're really seeing it come into fruition now, and it's really interesting in terms of some of the challenges which have come up around how we can go and scale these and really make use of this extra network bandwidth which is now available for so many other customers, and it's very exciting from that perspective to go and make the most use of that. I think really when we look at it from a kind of overall solution, if you're going from kind of data collection at the edge all the way through to kind of processing and doing the heavier data processing in the data center, there's still definitely value in having that edge compute around. And I think more and more there's going to be more value in what we can do to extract insights right at the edge. So, one of the things, and we talked about it from a product level, is with our VPUs. So this is what we have as NVIDIAs. And really with this, you can get it in a few different form factors, but really what it allows you to do is be running inference, but running it very efficiently. So looking at how many frames per second per watt is more of the calculation, which is, the bigger concern rather than just the raw performance at that point. And with technologies like that, and that's also encompassed into OpenVINO, so you're easily able to take advantage of it. You don't have to look at deploying a new software stack to enable it. As that with an example, it means that you're taking load off the network. It means that you're able to extract maybe other insights or capture more data and do different processing of that actually in the data center as well. And of course, there's always a cost with transferring data over a network. So even if you want to just be very efficient with how you have your networks laid out, that always is a positive.
Brilliant. So I was looking through the Intel website earlier on, and I know obviously a lot of people trying to get into this, they sometimes struggle of where to start. And I noticed that you offer a lot of AI courses, obviously trying to demystify that journey, give you a lot of the theory out there for machine learning, deep learning, and run through that. How big and how far does that extend? Is that something you've been doing for a long time? Is this relatively new? And have you got specific courses that you offer through there?
Yeah, absolutely. It's a good question. So really for us, we've been doing a lot of work from sort of several stages in terms of making this journey and making businesses able to go and utilize AI and to make use of the hardware we've got as accessible as possible. So there's kind of two sides of this. There's kind of the training side, and then there's also kind of what we can do from a software side to add as an efficient number of abstraction layers as possible. So you don't have to go in super deep when you want to start. You can still get some output, and you can get some real value from very lightweight models to go start with. Really what we've done from a hardware perspective to make it very accessible is we've got these neural compute sticks, which are effectively the NVIDIA's chip on a USB form factor. And with this, it's a great way to get started. You can plug this into a Raspberry Pi, for example. You can start utilizing some of our optimized software stacks and frameworks, and that really gives you a good understanding of what's actually making the biggest performance differences. How can I be very efficient in how I code for my models? And I think that's a really powerful starting point for any developer, right? There's always the concern when you get going, you can build amazing things, and then when you start to go and optimize, you realize you've kind of missed out optimizations throughout your journey. Whereas when you start on a very limited amount of processing power, for example, on a sort of small entry-level platform, it then gives you that ability to really understand where I can get as much performance and squeeze as much performance as possible from those platforms. And then when you scale, you can see that much more clearly where that optimization value has come from. So I think that's kind of the one part, and that's the part which makes it very accessible for users. The other part in terms of training, we've got lots of open and free training available. There's lots of case studies available in terms of how businesses have gone deployed this, and I think that's always very valuable to see. not just what can be done from a small home lab scale, but actually how kind of huge global deployments being set up, right? Are there things I can learn from how they've done it, which I think is always a really valuable stage. And then also we've got some really good YouTube channels which Intel hosts, which do training on here. We free videos. With OpenVINO, we've got a good video series which kind of covers getting started through to building a model using the deep learning boost, how you can take advantage of it, and kind of everything in between there as well. So a lot of that training is very aligned to the software side. But if you're kind of aligned to the software side, you're really making the most of the platform you've got from the get-go.
Brilliant. So it's really interesting there, Alex, that you mentioned a lot of case studies. We've done one specifically together very recently where we were with OpenGeoHub. Could you just talk us through obviously some of the more technical aspects of some of the optimizations, some of the implementations and the reasons why Intel benefited the team over at OpenGeoHub?
Yeah, it's really interesting question. It was a really interesting customer to work with alongside Scan. And there's a lot of value we get from working together with end customers here to drive those overall performance improvements across the board and make sure it's not just individual components which are getting optimized. It's that overall solution, from end to end. Absolutely. I think, and when we spoke to OpenGeoHub, from their perspective, it was very interesting. They're already natively doing a lot of their workload natively on CPUs already. And, a lot of that was a conversation, as we've mentioned quite a few times already, about, we've got all of these optimized software packages. A lot of them are already open sourced. They're all free to go and use. And it was really about kind of experimenting with those, right? And that's one of the real values of aligning to the open source community, making software free, is that you're able to go and test, you're able to go and examine and really understand what's going on below the abstraction layers you're looking at to make sure you're really taking as much performance as possible and delivering that to the actual workload you're looking at. I think when we go forward and we kind of look at where they can go in the future, they're really interesting in kind of scaling that and getting as much performance as possible. And that's one of those values where we're able to go from kind of that small edge device all the way up to exascale data center. So we can really align and support throughout that entire journey, no matter kind of where you are on that journey or kind of the scale you're looking to achieve as well.
We noticed that there's more and more data, as I told you. The data is going exponentially. So we started putting all this data together. And then we noticed, okay, now we have millions of points and we have terabytes of data. And we noticed, okay, now it's not only coding. Coding cannot save you anymore. You really have to get hardware. And then we also noticed, because we feed these global models, even space-time models, these models, just the model parameters, they're hyperparametric. They have so many parameters. So the models are like gigabytes. And so we noticed, okay, we need a lot of RAM also. We cannot just, have a small RAM. We're moving towards 1 terabyte of RAM now. So, we wanted to find the hardware that matches the type of problems we have. And that's how we started looking for this customized server. So we want to customize our server. And we know exactly which chips we want to use. We know exactly what are the bottlenecks, the RAM, the speed of reading. And that's how we came to Scan, because we said, okay, we can customize nicely servers. And your support at Scan was very friendly. So very happy with that. And they have their own AI lab. So that's a very good idea. So we could talk about the topic. So it's not only just a salesman, but people that understand the AI and machine learning. I like that they have a specialized departments, that they understand the fields, because you don't buy computers just to warm up your room or something. It's you really need the people who understand the applications. So that's one advantage of Scan. I think it was very easy to customize server via the Scan website. And also we could always contact the Scan colleagues and ask for question. And so that was all advantage of Scan, yeah. Well, we use, we have different solutions. We have the servers for storage, because it's a large data set. So we have now one solution where it's with a 20 terabyte SSD server. So this one is just to serve the data, so you can do point overlay, and you can do subset, so you can access data very quickly. Then we have servers to do computing. So that's where we do either model fitting and prediction. And then we have servers where we use for publishing. So these are like 3 groups of servers. The one for publishing, we don't want to make our own. So we just pick up a company to do the web hosting and web publishing. And there we can easily dedicate a cloud solution. But we use the scan service we use for basically for modeling and for prediction. That's the heavy computing part.
Basically, our workflow it's working on CPU. So we need to optimize all the levels of softwares, and Intel has like a specific implementation to optimize the numerical operation in a low-level library called Intel MKL. And we did some tests, and we create like our own benchmark using our own data. So it's an important part of the optimization process, because you can find some ready to use benchmarks, but it's not could be not really adequate benchmark for a specific case, as our case. So basically we tested it, and we optimized it using this Intel MKL that it's compatible with Intel CPU, and we noticed that it's 3 times faster than, for example, solutions running in AMD. So it's really important to us, this optimization, because it will reduce, for example, the computation time in 3 times. So, for example, if we run for 5 days in an Intel CPU, it will take 3 times more if we run in other way. So we try to optimize and create this customized benchmark, and specifically for our use case, and optimizing all levels of software and hardware. Right now, we have our customized workflow. So basically, we are using more conventional machine learning algorithms, like as random forest and other algorithms like that. But we know that there are some possibilities to use GPU to process this remote sensing data, and we need to explore it. And but right now our production workflow, it's already implementing like libraries that use more CPU and are more compatible with CPU. But we are investing to incorporate this GPU in our workflow, and I think the future solution for our case, it's really create like hybrid systems that combines, for example, GPU and CPU, using, for example, all the memory that we have available in the not only in the GPU, but in our machine. So, but it's an investment considering the solutions that we have available now.
What advice would you give to other businesses about investing in machine learning and AI?
So number one is start buying a one server or like a smaller version, and then build up from there. Of course, so invest very carefully. Also diversify. We do have also GPU and CPU servers, so you diversify from the beginning, and you consider that there are many ways you can reach a goal. Then benchmarking. Nothing can happen in, I think, machine learning with like good benchmarking. And when you benchmark, you have to benchmark all the processes. So don't forget, because we notice now it's so sensitive. I mean, you have this workflow of doing multiple things, and in that workflow you can have one bottleneck. So it's so let's say it's just a migrating data or just reading data from or splitting data into many tiles. And it's just a one bottleneck. And if you make a mistake there, your whole process is in danger. So yes, start testing, diversify, benchmark, and then scale up. Only then scale up, yes.
Alex, thanks very much for your time today. If
Sure.
anybody is sort of interested in exploring a little bit more on the Intel platforms, feel free to reach out to myself. I can connect you with Alex, connect you with the team over at Intel, and we can delve a little bit further. Please contact us at ai@scan.co.uk.